Good evening, everyone. I'm Sathwika from CSC department. In this video, I'm going to give a presentation on modules, packages, and libraries in Python. So, coming to modules and packages, as we create more and more classes, we need a way to organize them in such a way to make them available and easy to find. So, modules in Python are simply files. If you have two files in the same folder, we can load a class from one module for use in the other module. So for example, if we are building an e-commerce system and we create a single file or module that contains all the classes and methods related to accessing the database, then as long as all the other necessary modules like product, customer, inventory classes are in the same folder, then those modules can use the database module in order to access the database. A Python module, it can be defined as a Python program file which contains a Python code including Python functions, class, or variables. In other words, we can say that a Python code file saved with the extension .py is treated as a module. Now, when you import a function, for instance, you are essentially using a module. A module is essentially a Python file with a .py extension. Python module is a file of .py file. It contains variables, class definitions, statements, and functions related to a particular task. Now, a module in general, it is independent grouping of code and data and can be used in other programs. It can depend on other modules. Here, modules that are of variables and then functions are of variables, and here class, it consists of members and methods. Now we are trying to import the other modules of Python like variables, functions, classes, or types. And from here, we are importing other modules of Python, variables, functions, classes, or types. In the two ways, we can import a Python module. Now, coming to the structure of a Python module. A Python module, it can contain much more than just functions. A Python module is like a normal Python file, .py file. It contains one or more of the following objects related to a particular task. Now, if we consider a structure of docstrings, the task is to triple-coded comments useful for documentation purposes, and the variables and constants are labels for data, whereas classes are nothing but templates or blueprint to create objects of a certain kind, and objects are the instances of classes. In general, objects are representation of some real or abstract entity, and the statements are instructions for processing, whereas functions are named group of instructions. So we can say that the module ABC means it is file abc.py. Using modules. Now you can import a module using import module name and access the contents using module name and entity name. Now we can also access entities directly from module name, import entity name, or import module name alias module name or entity name. Here, Python module files, they have an extension .py. So these modules can be imported in the following ways. From an import statement to import the entire module, from statement to import selected object, and from asterisk statement, import all names from the module. And now we are importing modules from import statement. Import statement is used to include the modules in other programs. Syntax is import file name and example is import math. Now more than one module can be inserted in a Python program. The syntax is import file name and file name and file name. Now example for this is import math OS. Using import statement, one can view all the functions and other attributes of a particular module. Now example is import math. It is stored in a directory called math. Now we are importing modules from. Importing modules can be done using from statement. Specific attributes can be included in other programs. Syntax is from file name, import function name. The example is from math, import math.square root. Now, importing modules from asterisk statement, it can be used to import all names from the module into the current calling namespace. The syntax is from file name import asterisk, and the example is from math import asterisk math dot square root of 4. Here we can access any function by using the dot notation. The namespaces. When we import modules in a particular program, these modules will become part of that program and are called as namespace. Python implements namespaces in the form of dictionaries. It maintains a name to object mapping. There are three types of namespaces: global, local, and built-in. So if built-in is an entity or a namespace, then it consists of global namespace, which consists of local namespace. Now, module aliasing. Now, one can create an alias while importing module in a program. The syntax is import file name as alias name. Example, import math as m, then m dot square root of 4. Like module aliasing, members are also aliased. Syntax, import file name as alias name, member as alias name. And example is import test as t and add as sum. Now test.py is module file and is referred to as t, and add is the function. It is referred to as sum. The example for creating modules are can create the following and save it as an example.py. Now we are adding x and y, then we have to return x plus y. Now in another Python file called the add function, we use the following: import example, print example.add of 1 and 2. Here, modules have the name variable set to the module name. When a Python file is called as a script, then the name is set to main. This lets you create modules that can also be executed as scripts using the following: def of add x comma y, return x plus y. If name is equal to main, then we have to print add 1 and 2. Now, if we put a point class in a file module called point.docstrings.py, we can create another file module to include that class by doing the following. Now, we can import point.docstrings in p1 point.docstrings.point, and then coming to Python module search path, it's a Python path. It is an environment variable set with the locations where the Python interpreter searches for modules. Typically, the module search path is defined as Python path user local lib python x.x, which is the current directory. This is known as the current directory, the local library of Python. And now this is the program which is calling the point doc strings. If we import point doc strings, then p1.move of 22 and p2.move of 65. Here we are calling the point doc strings p1 and p2, and we are assigning the values x and y. Now, when we bring point doc strings into the calling program, we say that the point doc strings is now part of the calling programmer's namespace, which is the list of methods and classes available to the current program. Now, if we just want to bring one specific class in from a file module, we simply say that from point doc strings import point, and then we can also declare instances as follows: p1 is equal to point, and this is a program of calling point doc strings. From point doc strings we have to import point, then p1 p2 are assigned to the point, then we have to move 2 and 2, this is x and this is y value, and for p2 we have to move from 6 to 5, this is x and this is y. Here we are calling point 1 of x and y and point 2 of x and y. Then the distance which is covered from point 1 and point 2, and we are calculating the distance of p2 over here. And if we already have a class called point in the existing namespace, then we can use the as clause. From point doc strings import point as pt, and we declare instances as follows: p1 is equal to pt, and this is a program to call the point doc strings. From point doc strings import point as pt, then p1 is equal to pt and p2 is equal to pt. Then we have to move the point p1 to from 2, this is x1 and this is y1, And from point P2 dot move, this is x2 and this is y2. And we have to call the point 1 of x and y, and we have to call point of x and point of y. And the distance from P1 and P2 is calculated in P2. And if we want to import more than one class, we do from point docstrings import point line, but we should avoid doing this. From point docstrings import or asterisk. Now coming to organizing the modules. So as projects get larger and larger, it becomes more and more difficult to organize all of the modules with Python files in a single folder. In order to help with this issue, Python allows us to organize our modules into subfolders called packages. And the name of the package is nothing but the name of the folder. Now packages in Python. So we're going to learn what are Python packages, creating a Python package, an example of a Python package, the different ways to access Python packages. So what are the Python packages? Python packages are the same as directory containing other sub-packages and modules in a structured way, making the sub-packages and modules easy to access. And this is an analogy to a folder, as folders allow us to store files. Packages helps us to keep other sub-packages and modules to be used by the user when necessary. So Python modules can be categorized into packages by placing them within the folders, and the folder name becomes the package name, and it is used as a prefix with a period dot with a module name. Here packages can be initialized with a module named init.py. And here the Python packages are the collection of related modules. We can import a package or create our own package. And Python packages is simply directory of Python modules. The steps to create and import a package are as follows. First, we have to create a directory named geometry, then add modules area.py and volume.py. Then we have to create a file init.py and directory of the geometry. And this is an example file, so that the init.py files are required to make Python treat the directory as containing package. And next, the directory that contains the init.py file is defined as a Python package, and a package must contain a special file with name init.py. Init.py file can be empty, but a package can be imported the same way as a module is imported in order to create a Python package. So what is init.py file? So init.py file is simply a file used to consider directories on the disk as package of Python. It is basically used to initialize, the Python package. And Python searches module in the following manner. It searches in correct directory. And if the module is not found, then searches each directory in the shell variable Python path. If all else fails, then Python checks the default path, which is the installation location of the Python. And in order to achieve this, we place a file called init.py. In each subfolder we wish to be included in the project, like parent directory main.py we are drawing, and then init.py. Then we have to point call the py, and we have to point docstrings.py. Then finally init.py and the theorem.py. So here init.py we have called init.py. In each this subfolder we wish to be included in the project. So this is a folder called docstrings.py in math, and this is another subfolder of it called theorem.py. So here in drawing, there's an init.py subfolder, and it consists of theorem.py subfolder, math as well as the theorem.py subfolder. And so for the moment, we are going to assume that the special files, the init.py is empty, and we can import packages in two ways, using absolute import as well as relative imports. An absolute import is an import where you fully specify the location of the classes being imported. And We can do this in a number of ways. We can import drawing dot point call. P1 is point call dot point, and from drawing dot point call we can import point, then P1 is point again, or from drawing import point call, P1 equals point call dot point. Now this is a package module and it is a class where this is a package and this is the module. Now coming to relative imports. Relative imports is specific the location of the classes to be imported relative to the current package. Here relative imports is specify the location of the classes to be imported to the current package, and the current directory package and the previous directory package is the difference. So these are the relative imports. In the drawing, we have the subfolders called math, init.py, point call.py, and the point.docstrings. Whereas it consists of further subfolders called init.py and theorem.py. Now, if point call.py wants to call point docstrings.py, we can say that from point docstrings.py we can import point. So if theorem.py wants to call point docstrings.py, we can simply say that from point docstrings.py we can import point. Now using the init.py, if we wish to import a code directly from a package as opposed to a module, we can use the init.py in order to import the code from a package. So let's say if we want to get the point class from the module point docstrings.py, from the main directory we would have to say that import drawing.point docstrings.point. And now using the, if we add the following code to the init.py in the drawing package, from point docstrings import point, then from the main directory now we can say that import drawing.point. Instead of import drawing.point docstrings.point, we can use this import drawing.point. And if we want to import this class into a new module, then all we have to say is that from drawing import point. And if we want to import this class into any new module, all we have to say is from drawing import point. If it's almost the init.py file converts the drawing package into a module. Now the example of a Python package is the package of music application. Let's say init.py, signup.py. The sub packages are options, init.py, speed.py, repeat.py, and shuffle.py. With the sub package of playlist filter, it has init.py, singer.py, journal.py, and album.py. With the sub package play, it has init.py, start.py, next.py, and previous.py. Now, different ways to access Python packages. Now we can use different syntax to import packages in Python. The syntax import package name dot module name, import package name dot subpackage name dot module name, and from package name we can import module name. From package name dot subpackage name we can import module name, or else from package name dot module name we can import function name, and from package name we can import asterisk. So coming to the NumPy package, it is considered as one of the most popular machine learning library in Python. And array interface is the best and the most important feature of NumPy. This interface can be utilized for expressing images, sound waves, and other binary raw streams as an array of real numbers in n-dimensional. So this is an example to import NumPy as NP. Then we have array is equal to NP dot array of 1, 2, 3, 4, 5. Then we can print array and we can print type of array. The output is displayed as 1, 2, 3, 4, 5 and the class numpy.nd array. So let's print. So let's try to print the numpy array. let's open a new notebook for this. So let's first import numpy as np, and array is equal to np.array of 1, 2, 3, 4, and 5. We have to print the array. Later we have to print the type of array. So we shall run this. So 1, 2, 3, 4, 5 and the class numpy.ndArray is displayed onto the output screen. Now if we consider another example of 1, 2, 3 and 4, 5, 6. Then we have to print the array. We shall run this. Shall run this. So 1, 2, 3 and 4, 5, 6 are displayed onto the output screen. Now, moving to Pandas. Pandas is a Python library which is used for working with data sets. It has functions for analyzing, cleaning, and exploring, manipulating the data. It allows us to analyze big data and make conclusions based on statistical theories. It can clean messy data sets and make them readable and relevant. PyTSX3, it is a text-to-speech conversion library in Python. Unlike alternative libraries, it works offline. Now, if you import PyTSX3, engine is called pytSX3.init. Engine say I'll speak this text, engine.run and wait. So coming to Wikipedia, Wikipedia is a Python library that makes it easy to access and pass data from Wikipedia. And search Wikipedia will get article summaries and get data like links and images from a page and more. So if you import Wikipedia, sentences is equals to 2 refers to the number of line, and this finding result for this search where result is equal to wikipedia.summary of India, sentences equals to, then we'll print the result onto the output screen. Now organizing the module contents. So inside a module, we can specify variables, classes, or methods, and we can use modules to store global states without any namespace conflicts. As well as classes, we can share global objects across a whole system. Now, if we think about an e-commerce system again, which connects to a database, there should be one database class and one instance of a database object. Now, let's look at the case where there are several local copies of the database object. So the database module could look like the class of database, the database implementation, and the pass, the end database, where database one is equal to the database, and this is the database.py module. And then now any module we could call the database as follows. From e-commerce.database, we can input database one. Now there is potentially a problem with the previous implementation. As soon as the database.py is imported, the database object is instantiated. If this disconnect to a database, it will cause a slight delay while a connection is being made. So if multiple connections are being made from multiple imports, this will slow down the process. And we could rewrite this as follows. Class database, the database implementation, then we'll pass this. And the end database, where database one equals none. We are initializing the database of global database one, and then further database one takes the database value. Then we have to end the initialization of the database. Now that if the variable database one is global, then all of the modules can access it. This prevents the system from instantiating a new database object every time database.py is called. Now, if we want to differentiate between when a module is being called from another module or whether it is being called directly from the command prompt script, we can use the main variable and we can do the following. So this is useful.pipe. Then we have declared here class useful of class. Then this class might be useful to the other modules. Then we have to pass the statement and we have to end useful classes. And we have defined a main function of global database one, where database one equals the database, and we have to end the main function. If name is equal to main, then the script inside the main function gets executed and we can end the program. Now, up until now, we have assumed that classes contain methods and attributes, but in Python, we can have a class inside a method, which is as follows. So define format string of string and formatter none, where we can format a string using the formatter object, which is expected to have a format method that accepts a string. And we have the class default formatter which formats a string in title case. And we have format self string which returns string.title. Then this is the end format and we can end the class in this way. Now, if the string is not formatted, then formatter is equal to default formatter. And if we can return the formatter dot format of string, and we can end the format underscore string. Hello string is called hello world. How are you today? Then we have to print the input and concatenate with this with hello string. Then output, and we can concatenate the format underscore string of hello string. Now, if not formatter, then formatter is equal to default formatter. We can end this and we have to return the formatter dot format of string. And then we have to end the format string over here. Then later hello string is hello world. How are you today? Since we have printed the input of hello string, we have concatenated this with hello string. And the output we have to concatenate this format string of hello string. So the input is hello world, how are you today? Then the output is displayed as hello world, how are you today in the capital letters. That since we have used the title method, each substring, it has to be displayed in the capital. I mean the lower cases, all the lower cases letters are displayed into the upper cases letter using swap. Now the format string method, it accepts a string and optional formatter object, which by default is set to none. And so if the method is called with no formatter, it will be treated as none. If no formatter is supplied, it creates a formatter of its own as a local class and it instantiates it. Since it is created inside the scope of the function, this class cannot be accessed from anywhere outside of that function. Now, some Python modules are datetime, web browser, OS, hinter, and random. Datetime module, it supplies classes for manipulating dates and times, and the datetime module has many methods to return information about the date object. And here this is an example to return the year and name of the weekday. We can import datetime. X is equal to datetime dot now. Then we have to print x dot year. Later we have to print x dot string f time percentile a. Then output is displayed as the date and time. So let's try to run this. Try to launch the notebook. Now let's import date time, and then x is equal to date time dot date time dot now. Then we shall print x dot year, and then we have to print x dot string f time. We shall run this. So it's been displayed as 2024 and Friday. Now heading back to the program. So coming to the web browser module, it includes functions to open URLs in an interactive browser applications. Then the module includes a registry of available browsers. In case multiple options are available on the system, it can also be controlled with the browser environment variable. Example, to open a page in the browser, we use the open function, and we can import web browser in the web browser.open with the link. Now the OS module in Python, it provides functions for interacting with the operating system. OS comes under Python's standard utility modules. This module provides a portable way of using operating system depending functionality. The OS and OS.path modules, they include many functions to interact with the file system. Some functions are os.remove. Os.remove method in Python is used to remove or delete a file path. This method cannot remove or delete a directory. And os.mk directory. Os.mk directory method in Python is used to create a directory name path with specified numeric mode. Now, os.list directory method in Python is used to get the list of all files and directories in the specified directory. If we don't specify any directory, then list of files and directories in the current working directory will be returned. Now, Kinter. Kinter is a graphical user interface GUI module for Python. We can make desktop apps with the Python and can develop GUI applications like calculator, login system, text editor, etc. Kinter widgets provides various controls such as buttons, labels, and text boxes used in a GUI application. These controls are commonly called as widgets. An important method of Kinter is that Kinter screen name equals none, base name none, and class name equals tk. Use tk equals 1. This method is mainly used to create the main window and the main loop function. This method is used to start the application. The main loop function is an infinite loop which is used to run the application. It will wait for an event to occur and process the event as long as the window is not closed. The random module, it is a built-in module to generate the pseudo-random variables. It can be used to perform some action randomly, such as to get a random number, selecting a random elements from a list, shuffle elements randomly, etc. Now, method of random, the seed method, it initializes the random number generator. Get state, it returns the current internal state of the random number generator. Set state, it restores the internal state of the random number generator. And choices, it returns a list with an element from the given sequence, whereas random, it returns a random number between the given range. Now coming to Python libraries, we have learning objectives to understand the libraries using standard library function and creating a Python library. So a library refers to a collection of modules that together cater to specified types of needs or applications. Some commonly used Python library are the standard library, NumPy library, SciPy library, Kinter library, and Matplotlib library. So standard library, this library is distributed with Python that contains modules for various types of functionalities. NumPy library, this library provides some advanced math functionalities along with tools to create and manipulate numeric arrays. SciPy library, this is another useful library that offers algorithmic and mathematical tools for scientific calculations. Whereas Kinter library, this library provides traditional Python user interface toolkit and helps us to create user-friendly GUI interface for different types of applications. And Matplotlib library, this library offers many functions and tools to produce quality output in variety of formats such as plots, charts, and graphs. Now, some commonly used modules of Python standard library are math module, CMath module, random module, statistics module, and URL module. And the math module, it provides mathematical functions to support different types of calculations, where CMath module, it provides mathematical functions for complex numbers, and random module, it provides functions for generating pseudo-random numbers. Coming to statistics modules, it provides mathematical statistics functions. And URL lib module, it provides URL handling functions so that we can access websites from within the program. So what is PIP? PIP is a package management system which is used to install and manage software packages written in Python. So to check pip version, we can run pip version at dos prompt. This is the command. And so far we have learned about the Python library, types of libraries, modules in Python, packages in Python. We also looked at creating package or library in Python. So that's the end of the presentation. Thank you.